So we are moving forward into solutions, digital and sustainability, the next wave of innovation in foods. Let's go. It's very important to go through solutions. We start with a presentation. So we have here Patrik Sandin from, he's Swedish, is working at Bain, a top strategy consultancy in Copenhagen. And we have here Ricardo Chagas for Food for Sustainability. Let's start with Patrik. Patrik is going to present the conclusions of a very fresh, new study that they've been presented.
Thank you, António. Pleasure to be here. As António said, my name is Patrik Sandin. Work with Bain & Company, a global strategy consultancy with over 13,000 people in close to 40 countries. Most recently, we set up an office here in Lisbon as well. As you may know, the global food system is a very important and large sector, right? It represents a third of global GDP, and it employs 40% of population or working population, right? And we also heard that we have been increasingly successful at feeding the population. We produce now more food than we can actually consume. This will, however, change with growing population and the effects of climate change, but still, to this day, we have a very effective food system driven by many innovations over the years, right? Fertilizers, different production methods, etc. However, there is unequal access to this food. We heard that 820 million people go to bed hungry. However, 1 billion people more are obese. Food, as you know, is wasted, and actually 40% is post-harvest retail consumption waste. A lot of the post-harvest, harvest-related waste is in the global south, the developing world, where we have a lot of food production, whereas most of the per capita food waste is occurring in the global north, the developed world. Okay. Okay. Now, as I mentioned, 40% of population works related to the food industry, right? But 80% of the extreme poor are working in this industry as well. It means that we have a huge kind of wealth pay gap related to this industry as well that needs to be tackled. Food industry also, through the packaging and all the plastic used throughout the supply chain, makes up 80% of the marine debris, and in addition causes about 70% of water withdrawal, 60% of oceans used for fishing and increasing, in addition, of course, then to the fact that we are overfishing and we're soon out of fish. We have more plastics in the ocean than we have fish. This is huge problems that the industry is causing and will need to deal with somehow, right? In addition, biodiversity, agriculture causes 86% of species being at risk of extinction. It contributes to 40% of the habitable land use. 20% of the global greenhouse gas emissions is caused by the food industry. So we're seeing here lots of problems that the industry needs to deal with, including how we are actually treating all those animals that produce our protein, right? 99% in developing countries like the US is factory farming, not the best conditions. So what Bain did was we looked at these, what we call externalities, the negative impacts that the food system is causing throughout the value chain, and somehow rating these or weighing them in degrees of severity, of course having numbers behind all of this as well, right? We worked together with the World Economic Forum for the last 6 months or early 6 months of this year in a study to look at these externalities and then see how can we leverage fourth industrial digital technologies, also called exponential technologies. And here we have technologies such as AI, 5G, 3D printing, drones, robotics, precision farming, which are using some of these technologies. And what we're seeing is then looking where can these technologies be applied to solve some of these negative externalities, right? And what we came up with in collaboration with World Economic Forum and all their member companies related to food and food retail, and with them discussing, so out of all of these potential technology solutions, these negative externalities we see, which solution areas do you believe and do we believe have the most potential impact that we can rally around, that we can get players across the value chain to be interested in investing and pursuing? And these are the 15 solution areas we came up with, and we grouped them into 4 investable themes, as we call them. Those 4 investable themes: supporting farmers digitally, creating end-to-end data transparency, reducing waste, enabling circularity, and nudging consumer behavior. I will quickly go into some of the solutions or give one example per investable theme here. So imagine if farmers could easily connect with one another and share information. That could have, potential massive impact, because a lot of the farming, we have 500 plus million small-scale farmers, right? And they don't necessarily have access today to the latest technologies and the latest insights. So if we could enable them to be connected, like We Farm, for example, here, which is a startup, and they have a platform using digital technologies where farmers can connect, learn from each other, learn about different, farming methods, learn about different input, feedstock, different fertilizers, what have you, and that can significantly then impact the efficiency of farming and reduce their harm to nature, right? Right now, 2.4 million farmers are onboarded onto that platform. Looking at end-to-end data transparency, then imagine if consumers and supply chain players had full information of the food across the life cycle, right? So we know where it was produced, who produced it, who handled it, what waste, etc., right? All the externalities. This would be quite interesting because 72% of consumers say that they are interested in understanding the negative impacts of their food, or the health, nutritional impacts of the food they're eating. So a large player, it doesn't always have to be startups, but this is an internal startup within Olam, a Singapore headquartered large agricultural player that is a global supplier of products like cocoa or coffee beans, etc. They developed at Source, a platform, a tool to assess and report and have transparency on all the environmental and social sustainability impacts of the food from farm to fork. So far, 30 of their products are on this platform across 30 territories. Now imagine if food prices, and we heard this from Michal just now, this is one quite interesting technology. If you could actually have dynamic pricing, you would enable the retailer to actually earn revenue instead of causing waste. You would have people incentivized to buy the product before it goes out of date. Right now, 30% of food is thrown away in the store. Wasteless, a startup, is using AI, big data, RFID, and other technologies to enable just that. And the effect is quite staggering: 33% reduction in food waste at the retail level, 6% increase in revenue for the retailer, right? So it's a win-win: consumer, retailer, and planet. Now, another thing that we hear quite often is that people don't understand if the food is sustainable or not. And there are so many different metrics, different labeling schemes, different ways of communicating the sustainability impact of the food. We see this in other industries, Higg index in the textile industry, for example, which has been around a long time, recently coming under criticism for their public-facing reporting, partly because in their case favoring certain materials like synthetic, which might not be more sustainable than cotton, etc., right, and have huge impact on microplastics, etc. In the food industry, though, we're lacking this. We have, in many countries, different labeling schemes, swan, keyhole, whatever it might be, but consumers don't understand what it means. So we need a simple and common way of presenting this data. Now, Provenance is one company that is trying to create that, again, a startup, and what we're seeing now, early stage still, but 27% conversion rate, so people who actually see this information is attracted or make sense of it and actually then proceed to purchase. And 2.8 times the engagement using this tool, right? So I think it has huge potential. Now, the conclusion, I think, of this study, and I will talk about the study a bit more later as well, is that as players, big players in this food industry, it's important to leverage digital technologies. And when doing so, first figure out, do we have a positive impact from this, right? And does it generate financial benefit both for us as a retailer, as a brand, as a supply chain company, and give some kind of benefit to the end consumer as well? Otherwise, we're not going to get traction on this. Many startups, sustainable startups, are struggling to get traction. We have the solutions are out there, but we're not scaling fast enough. And so what we need to do is to innovate faster together. And I think all of us can play a role here. A student can come up with a cool, innovative startup idea. A person in a large corporate can find those people, those startups, start collaborating, right? But what we're seeing in, Michel talked about transition labs. That's one way of collaborating around a problem. Now, to build businesses, I think not only do we need to have that common language, the common understanding of a common problem defined, but we also need to have an understanding of the incentives, an understanding of how, as a business, we can make money from this, and how we separate what is pre-competitive that we can collaborate around and actually have joint solutions and scaling, and what is competitive that we can differentiate as a business. At Bain, we support companies on doing just that. So we help setting that innovation strategy. Me and my colleagues in the innovation and design team at Bain, we work with large businesses to build these new startups, these new ecosystems that are needed, and really create those long-lasting collaborative ecosystems. Going back to the study, so we published just before the summer an agenda blog with the World Economic Forum that you can take a look at here, how digital technology can accelerate food sustainability. James Anderson, my co-author, partner in London office, and we also published this on the Bain website. But more importantly, I think, and perhaps more interestingly, for you to explore, we developed this tool, which is an interactive tool where a lot of the data we talked about, a lot of the startups and solutions we found can be explored, clicking on a specific technology and seeing which parts of the value chain that can contribute positively to what externalities we see from each step of the value chain and which technology can then support in reducing those externalities. So scan the QR code, play around with this tool, and any questions now, António from the audience, happy to discuss. Thank you.
Hello, Hansjorg, can you hear me?
Yes, I can hear you.
Oh,
Hello.
how are you? Good morning.
I'm doing fine. Good to see you again.
Good to see you. Good to see you. We did business together. Hansjorg is in Germany, and we worked first in renewables, in a major project in renewables, new type of renewables, and now we can find Hansjorg. You can present a bit yourself, but on a domain that is very interesting, biochar. Please.
Yes. Well, thanks a lot. Let me share my screen, and then I will go right into the presentation, talking about biochar, climate change mitigation, but also about food and what this has several impacts on food. So let's go started. So first of all, I'm talking about biochar. And what is biochar? Biochar is basically carbon that is derived from thermochemical processing of biomass with a limited oxygen, in a limited oxygen environment. And therefore, what you can create is a carbonous materials, and it's a highly versatile material that can be used in a broad range of applications. Now, we're not talking about kind of a campfire and producing char as it was produced back in the Middle Age. We're talking about high-tech equipment where on one side we feed in biomass, then there's the technical equipment, and that converts the biomass into heat, in some cases even electricity, then in all cases biochar, and along with the biochar there is negative emissions going along, which is kind of the opposite of CO2 emissions. And I guess I don't have to explain where we are in terms of climate change. The world is getting warmer, and that creates a huge problem also to farming and agriculture, because higher temperature also increase more critical effects in terms of very high temperatures, droughts, floods. So farming is really under pressure due to climate change. And if we look at what we have to do to achieve to prevent the worst in terms of climate change, we have to do two things. First of all, we have to rigorously reduce emissions. That's the brown curve. We have to reduce our emissions much faster than we managed to grow the emissions in the past. But it's not enough. If we only do the emission reduction, we will end up at a worldwide average temperature between 3 and 4 degrees. So what we have to do on top is we have to take CO2 out of the atmosphere. And there are a number of solutions. Some of them are well known, like afforestation and using wood as building material, or also soil organic matter, very important means to create, to bind carbon in soils. But those two options have in common, they're good, they're great, but they have in common that that the carbon is not really stably. If we stop the relevant practice, the carbon can be released again. Now, there are, as of today's main solutions, there are 4 solutions where carbon can be bound permanently, and I won't touch the lower ones in any detail: direct air capture, bioenergy carbon capture and storage, and enhanced weathering. And I will focus on biochar, or as we also call the process, pyrogenic carbon capture and storage, as a means to combat climate change. And how does it work to bind carbon with biochar? I mean, we start with the nature. We start with things growing and binding trees, but also any agricultural products growing and binding carbon out of the atmosphere. And then we have the technical process of the pyrolysis that makes the carbon recalcitrant. It won't if you add it to soils, it won't degrade. But then there is a process that we call conditioning. The carbon has to be conditioned to its final application. And there are three main applications for biochar. That is in agriculture. It is in urban environments. City trees, for example, grow much better in soils where biochar is added to. And last but not least, there is the application in building materials. And all have in common that the carbon is permanently stored and taken away from the atmosphere, which is what we have to do. Now, I want to focus in the following on agriculture, but I don't want to be let unmentioned the two other ones. It's urban application and construction materials. But now focusing on agriculture, well, first of all, we are observing an incredible dynamics in science in biochar, and most of the papers are really on agricultural use of biochar. And what that means is that when people are looking into biochar, it's really important that they look at the very recent papers. So, I mean, if you get a paper, if last time you dealt with biochar was back in 2014, then you look at old papers that does not fulfill, then you're not up to date. So it's really important to be up to date. Now let me focus on where biochar can be used in agricultural fields for soils, for improved fertilizing or for improved soil fertility. There are 7 systems where biochar can be used in agricultural systems. The first one is on fields where there is yield increase and nitrogen oxide emission reduction. It helps creating more humus. It improves the water holding capacity, reduces nutrient leaching, and then I don't want to go into all detail here, but as you can see, there are a lot of different applications of biochar. You feed them to animals. You can do co-composting with biochar with positive effects on climate gases and improved compost quality. It can significantly reduce the odor from manure and improve the nitrogen usage. And and this is not me saying that. There is, in the meantime, very solid research. And what you can see here is probably the most relevant scientific publication that summarizes 27 meta-analyses that show how compelling the evidence of the benefits of biochar in all investigative agronomic parameters is. And I want to give you just a few examples. So the blue bar, 1, 2, 3, 4, 5, 6 from the top is water use efficiency. So plants can better can use the water more efficiently. Roots grow better. The soil available, the plant available water is improved. And so there is really a broad range of advantages of using biochar in agriculture. Now, I just mentioned before that we are not talking about kind of campfires. We're talking about technical equipment, and I just want to give you a snapshot on how that industry is developing. So we created the European Biochar Industry Consortium because Europe is leading in terms of equipment manufacturers, and we have now really a nice ecosystem of companies growing and being available of providing biochar and biochar products. What is important is that, I mean, there is a broad range of suitable feedstocks that can be used to be carbonized. And I don't want to go too much into detail, but it's really a broad range of applications. Obviously, when it's about using biochar in farm applications, we wouldn't want to use waste wood, but we can use forest residues, we can use materials from the food industry, we can use straw as a raw material, and also very interesting application is sewage sludge, which doesn't make sense to be burned. And that's kind of my point. We have to create carbon sinks, and biomass is already a carbon, is a carbonous material. So if we burn it, we're gonna release it back to the atmosphere, and that is pretty bad. So we have to rethink the way how we deal with biomass, and then we can create a new system that creates biochar, both for climate change mitigation and also soil fertilization or city trees, improved growth of city trees. And I mean, the industry is growing pretty fast. So we have growth rates in the last 2 years between 70 and 80%. And the vision we are driven by is that we really become climate relevant very soon. So today, biochar is the most relevant negative emission technology. And if we could maintain the growth for the next 15 years, we would be climate relevant. And there is enough biomass to be pluralized. There is enough application cases for biochar in agriculture, but also in other applications. And if we follow that, we can achieve that biochar will be climate relevant in about, in less than 15 years. So thanks a lot. And thanks, António, once again for inviting me to give that presentation here.
Thanks a lot, Hansjorg. Any question? I have here a speaker, that is Ricardo Chagas from Food for Sustainability, but I wonder if there is any particular question to Hansjorg on biochar? Yes? Let's go.
Just good morning and congratulations for your presentation. I have just one question, is how sustainable is to cut forests to produce biochar?
The main idea is not to cut forests. Very clearly, we won't cut forests to just produce biochar. It makes more sense to use forests to produce wood, but then there are a lot of residues remaining from the wood production, and then these residues should not be burned but rather pluralized to maintain as much of the carbon possible that is in the wood residues. It's about waste streams. It's about pluralizing waste streams.
Thanks a lot, Hansjorg. Thanks so much. Well, we are recording all these, and we are going, of course, to keep sharing all this information. It's very, very important. This is an event that is a movement in place. So we will gladly, as we mentioned with Israel on food waste, we want to keep partnering and promote all this. Same with Patrik. Any particular question to Patrik about all these digital solutions? Of course, you saw there is the QR code, that is the possibility to explore the study full of solutions. But Patrik, any particular surprise on the study where you before starting the study, where you had an idea and then you came to a different thing?
No particular surprise. I would say that we started the study at the time when the Ukraine crisis happened, and obviously that put another set of complexity and strain on the food system, right? And I think the traceability solutions, any solution to enable, optimizing the yield, and that could be precision farming and using less resources, is, I think, increasingly needed for the global supply chain to function, right? So it enables more localization. Add to that the possibility, which is not even explored yet, I think, is we're seeing digital, what do we call it, digital twin in manufacturing. It's been quite popular to have IoT devices and have a digital representation of your factory. We're seeing this now as a possibility to be expanded to the farm level. So imagine then if you know exactly where all your cows are, how they're feeling, you have sensors on them, you know your crops, you know the weather data and all of that, right? And then you can model, you can plan exactly how to make use of your resources, right? So I think that's another possibility, and that coupled with the sort of transparency solution. So what if your buyer, your retailer, would then have that kind of put on a VR goggle and you can see exactly what's going on across the supply chain, right? I think it opens up so much potential which is untapped right now.
Any articulation, we'll come in a minute to precision agriculture and digitalization, but any particular topic, anything that comes to your mind with this presentation on biochar?
No, but certainly related. I think, as I mentioned, the food industry contributes so much to global warming, CO2 emissions, etc. Farming practices and regenerative farming is very much needed. I think that there is a lack of understanding of regenerative farming, so there is a huge opportunity for investing in, for companies in the industry then later in the value chain to invest in education, in communication of the benefits of that. And I think there could be a good symbiosis then with the biochar technology as well.
So let's now move to many things. Let's now move to Ricardo Chagas from Food for Sustainability, bringing in a Portuguese angle of advanced things happening.
Thank you. Thank you. So, can you read? Yeah. Okay. So, good morning, everyone.
Be careful because all the picture is behind you.
So, what a pleasure to be here, and thank you, António, and thank you to the organizing committee to invite us to be here today and to show you a little bit of our work. So I work at Food for Sustainability. I'm the technical and scientific director of this co-lab. The co-labs are fairly new entities in Portugal that are linking the academia with the SMEs with the objective of bringing value to the companies and putting in action some of the things that we are doing on research that are very important. Today I will show you the point of view solution in Portugal with a specific to a specific type of action, in this case related to digitalization. A little bit on what Patrik already said. I will focus on another of the topics that was in the left of it, and I will read it because it's important. Digitalization is a transversal process that must be adopted in all production systems to increase their competitiveness. So what this means is that we don't need to be or to say that we work with precision agriculture, because precision agriculture is not a production system. Is a toolbox that every producer can use in their exploration and can benefit from it. And nowadays, the producers have a huge tool with them, that is this. So if you have a cell phone, you have a lot of functionalities already available and free to use. And one of the things that these type of actions, so the digitalization that we talk, that is being adopted by big companies right now, but must be adopted for small producers. And that is the challenge. The big challenge is how can we use this on small producers at a low cost and high efficiency. So one of the things that we can look into it is satellite imaging and how to use the satellite imaging on our productions. So nowadays we have a lot of advantages on using them, and it's cost-free. So if we look into using the Sentinel-2 imaging, in 5 to 5 days we have the image from our fields, and it can be pre-processed if we go to the right sites. It has some disadvantages like special resolution and the mixture of targets inside the pixel, because if we are looking into a pixel is 15 meters and we can have some type of confusion. And if we know that we are working with small producers, what we have very small portions that we need to tackle, and it can be very difficult to it. And one of the possibilities that we can explore is a technology that is not so new in agriculture, that is the UAV imagery. But because it's not new, but the capabilities that we have are huge. So if we look, for example, into a Sentinel image of the terrain, that is the second one, and you can see that the pixels, we can see already some definition. But if we go to the MicaSense, for example, if we look into the UAV imaging, we can see a lot of definition in that part. So the challenge is how can we use the Sentinel-2 in a way or in the same way as we can use the imaging from the UAV. So this is the challenge, to improve spatial resolution of satellite imaging. It's one of the challenges that we are working, and we have already a project ongoing on that part. We can look into the traditional methods, and we can work with the Sentinel and try to increase by interpolation this type of imaging, but then we can use deep learning. And deep learning can give us a tool that is to how can we pick the images from the UAV, from specific cultures, if we are looking into vineyard, if we are looking into some type of other type of fruit or almonds or olives. And we can use deep learning to pick the images that we have in high resolution by UAV. We can pick the image low resolution from the satellite, and we can try to do deep learning and to build an image that is like this. And what this means is that without using drones on that specific producer, we can pick imaging from satellite, and we can achieve a resolution very close to a UAV. These are two examples, exactly the same. So if we see the UAV image, the satellite image, the interpolation, and the final image that we can achieve just with the satellite imaging. So this opens a lot of possibilities now to agriculture. We can look, for example, into improved plot designs. And in this case, it's a plot design that I will explain in another block today. That is to almond producer that is working with us. And we have here 2 plots that were done by satellite and then by UAV imaging. And then we treated the plantation lines in 2 different ways to test new approaches. We can look into precision nutrition management. So we are looking into digitalization. Once again, as Patrik said, we need to produce more with less. So we can look into exactly what is the deficit on nutrition on specific plants if we can increase the definition on the terrain that we are working. And that is very specific, for example, to Portugal. If we go to the north, for example, we have a lot of small producers, and they cannot use, for example, it's just 1 pixel or 2 pixels of the satellite imaging. And once again, measuring soil organic carbon. This is a huge objective that we have. In the European Union, we already have the maps of GSOC that gave us some type of information regarding the capacity of carbon sequestration by a specific soil. But if we can do it with a drone, it will be much higher possibilities to to explore. So once again, we have digital technologies that can be smart in precision farming, as this is just one of the examples that I showed. We can enhance the accuracy of agronomic forecasting. This is very important once again, because we don't have enough agrometeorological stations to do all of this, and if we can do deep learning also with this and use AI to do this interpolation, we can predict more closely the agronomic forecasting. More precise and effective use of inputs while reducing environmental harm. Once again, produce more with less, and go to a carbon neutral agriculture and to a more resilient systems. So the new CAP that is already here, we are starting, has a cross-cutting goal of modernizing the sector by promoting knowledge sharing, innovation, digitalization in agriculture and rural areas, and promote its adoption. So this is right now, and member states are obliged to develop a digitalization strategy for agriculture and rural areas. So we cannot look into digitalization as something in 10 years or in 15 years, because we are working right now on these parts. And just to finish my presentation, I would like to show you one of the projects that we are also involved, that is a digital innovation hub. So the digital innovation hubs are knowledge hubs that work in collaborative networks in Europe. The focus is to disseminate advanced digital technologies. In our specific case is on agriculture. They work with providers, and the main targets are companies and public administration. So these hubs are non-for-profit. They are complementary to market, so the objective is not to compete directly with the market. They must be open, transparent, and non-discriminatory access. And you can see the site, and you can see the type of services. So we have 19 services right now, with 28 entities in this specific consortia. And we are one of the 22 DIH that are working on the agri-food sector, really looking from farm to fork. And we have the PRR, so the national PRR financing to this. So if you want to know a little bit more regarding our Digital Innovation Hub, please see our site. Thank you.